So, this is week one. Welcome to the week one, and I'm Jyoti Sharma. And this is week one, and session will be from 6 to 8 only. And let me give you my brief introduction. So, right now, I'm a PhD student from ISO Bhopal, and my master was from Forest Research Institute, Dehradun, and my undergraduation was from University of Delhi. I already have qualified NET JRF, and I also already have taken some live session for air pollution and control, environmental chemistry and microbiology, basic environment engineering and pollution abatement. So I hope that with my past experience on NPTEL, this course will this will help me to move with the smoother way, right? So, and how we will solve the questions and how we will discuss to each other. So this is how we will proceed. So I will have a lot of MCQ question and we will try to find out the solution. You will give me some answer. I may or may not correct you, but I will try to correct you. And your participation is highly valued because whenever you will participate, I think that will help you learn more. And this is also win-win situation because I will also learn from you, right? So it will be better that you participate, you can communicate, you can write in the chat box, in any way how you are comfortable, you can go with it, right? So let's come with whatever we have. Okay, so every week I will have some MCQs, and these MCQs will be based on previous week that sir already have taught to you. And this is for week one. So this is primarily we will talk about the introduction, and this introduction is nothing source to environment to the receptor. We will talk about this, how this chain is moving from one point to the another point. Then chemical of concern, what different chemicals we have in the environment and why we are concerning about such chemicals. Then water quality and screening parameters, so what parameters we should know to check the quality of the water. And then air quality parameters, and then we will talk about the particulate matter. But before that, I want to ask you your subject expertise, whether you are chemistry expert or environment expert, so that will help me to proceed with the MCQ, the level from basic to advanced. So can you write in the chat box, or even you can communicate? I don't have any problem with this. Uh, in which course you are enrolled already? Can you write in the chat box or communicate quickly?
Excuse me, ma'am. I want to ask something.
Yeah.
Actually, I have just joined this on 25th, so I am not aware where we have to submit the assignment and all.
Assignment.
Yes, ma'am.
Assignment is you will have a lot of MCQs question that is only uploaded on the NPTEL, and you will select whatever right or not, and then there is a submit button at the end, and that's how the assignment will be submitted automatically.
Actually, this is my first class, so I am not aware.
Okay, it's no problem. But whenever you will go to the NPTEL, in NPTEL, you will go to the this course, and within that course, after 4 or 5 lecture within a week, there will be the assignment tab. And if you will click on that tab, there will be multiple questions MCQ, and you will select which one is the right option, and then there is a submit button in the bottom, and this is how you can submit.
Okay, ma'am, thank
Okay, so what I learned is that Tanya is MTech engineer, environmental engineer. Oh, that will help me also because you must have a lot of knowledge about environment.
you.
And
Physics.
Rahul, you are PhD mechanical engineering working on energy and environment. Oh, that's great. And from where you are doing your PhD, Rahul? Okay, so it's it from Bits Pilani, Rajasthan, right? This nice. Okay, so actually, first we are gonna start with. So this is right now for this week one. This is almost environmental science only, and then I think we will proceed with more technical. But right now, there we have to understand the science, environment science, not right now the engineering part. So I think that will be the great opportunity for you to have knowledge on environment science also. So anyway, uh, so first we're gonna start with understanding the source environment receptor framework. This is very simple, but I think you need to understand. Okay, Sandeep Kumar have expertise. Okay, so he's doing BS Physics from IIT Kanpur. Okay, that's also great. Uh, okay, so this is very simple question. In the source environment receptor framework of environmental quality assessment, the term receptor refers to what? So we have four options here: the medium where pollutant accumulate, the entity that receives exposure, the process generating emissions, and D is the chemical composition of the pollutant. And I would request you people to give the answer, whether wrong or right. I will try to correct it. So I think that's how we can engage with each other, and then like we can learn. What do you think? What should be the right option for this question? The term receptor refers to what? Okay, Dhanya. Okay, so I'm getting B answer from Dhanya, from Rahul. Yes, I agree with this. This is any identity that receive exposure. Now, my next question will be, so if it is any identity, so it means it can be some building, or it may be plant or animal, or it may be human, right? Or is it not? Identity means what? It is just the human being, or plant, animals, or for example a building. So for example, I'm saying that Taj Mahal is getting degraded, or the color of the Taj Mahal has been is being converted to the yellow. So Taj Mahal is the receptor or not? Okay, so the thing is, receptor is anything, right? It can be building, it can be plant or animal, or it can be human that receive the exposure to any toxic thing, or to anything that may be harmful to any of the identity. But the thing is, right now we will just talk about human as a receptor, because we are most of the time are concerned about human, right? So no doubt here identity means human, plants and animals, buildings, etc. But we are right now more focused on human as a receptor. So B is the right answer. Okay, so let me just give you more example about this. How we are the receptor. So, for example, there is an oil spill. So, what will happen by oil spill? There may be that we have fishes, and on that fishes there will be the deposit of the oil, and if there will be the oil deposited on the fish skin, then that may inhibit the swimming potential of the fish. So this is how the fish may be the receptor, uh, and may bear the bad effect of oil spill. uh, if I'm taking the example of CFCs, so because we know that CFCs help us to deplete the ozone, right? And if the ozone will be depleted, it means some ultraviolet radiation can come to the earth and can burn our skin, right? And we may also have skin cancer due to this ozone depletion. So CFC was the source, there was some environment in which some changes has been happened, and then ultraviolet radiation will come to us, and our skin will receive that effect. So human will be as a receptor. So this is how we can understand from source to environment to receptor. Okay, so next question is again very simple. Which one of the following sequences correctly represents the pathway of pollutant leading to health effects? So we have source to exposure to environment to receptor, emission to source to receptor to environment, source to environment to exposure to human health effects, environment to source to exposure to toxicity. Okay, Dhanya gave me option C. Okay, yeah. So yeah, I also agree with this C only. And why this C? As I gave you the example, right? If the source, you can say source is somewhat a process only. So, for example, if there is a combustion of wood, let's say, the combustion will give you CO2, and it may also give you carbon monoxide, right? And this carbon monoxide will go to the environment, and you will be exposed to that carbon monoxide, right? And so after that, that will give you the health effect to the human. And this is how the sequence will be: source to environment, environment will give you the exposure, and that exposure will be taken upon by the receptor, and that receptor is human, and that's how human health will be impacted, right? Now the question is, in the given framework, inhalation, ingestion, and thermal contacts are collectively referred to as what? We have four options here: environmental compartments, emission processes, exposure pathway, toxicology endpoints. Lakshmi gave me C answer. Dhanya also gave me C. Okay, yeah. Rahul, yes, the C answer is the right one. Right now, we are just moving with just the simple framework from source to environment to exposure to human, and then we will go to the next topic. But I think this is the basic that we need to learn first. Okay. So, in the environment, we have pollutant, right? And that pollutant can be taken up by the human by different ways, right? This can be by inhaling or breathing the gas, or it may be eating something. For example, we are having food, and food is contaminated by, let's say, lead, or by maybe some other heavy metals, and we are eating it. So this is the ingestion. And it may be the thermal contact. So for example, if we have ozone, and ozone is yeah, impacting us on the skin, so this is the thermal contact. So environment have some pollutant, and that pollutant will be taken up by the body using these pathways: inhalation, ingestion, or thermal, and we call these pathway as exposure pathway, right? So I think this is very clear. If it is a air, so if we have contamination or pollutant in the air, most of the time what we do is we will inhale it, and that's how we will be exposed to that particular pollutant. If it is a water, then we can we can do the ingestion, or there may be that we are in the contact with the water. So let's say if we are washing or if we are bathing in the river, then that may also give you the thermal contact, and this is how this can also expose you to the pollutant. Then food and soil, mostly these are the pathway will be ingestion and thermal contact only. Okay. So the next question is, which of the following environmental compartment is most directly associated with bioaccumulation and biomagnification of contaminants? And we have four options here: air, water, soil and sediment, plant and animals. So first you have to understand what is bioaccumulation, what is biomagnification, what is the difference between these two, and then which environmental compartment it is associated to. Danya, Rahul, Lakshmi all gave me C answer, and obviously the answer will be, sorry, D answer, and obviously it will be the D only. Why? Because there is a biomagnification or bioaccumulation. So bio means anything living, right? And among these four options, we have living option is plant or animal. But can you tell me the difference between this bioaccumulation and biomagnification of the contaminant? Is there have you heard about this term bioaccumulation and biomagnification earlier? So bioaccumulation means uh, some contaminant you are taking, you are exposed to some contaminant. uh, what is yeah, Sandeep, I'm trying to explain it right now. So bioaccumulation is uh, in the living body. Bio means living, right? In the living body, some contaminant is we are taking some contaminant in the living body, right? And with the time we are taking it, we are taking the contaminant, and over the time what we will get to know that we will have more contaminant in our body, right? This is bioaccumulation. So we are accumulating that contaminant in our body. So this is bioaccumulation. But biomagnification is different. Biomagnification is what Lakshmi already have told me, already have written the right explanation of this. So this is, if we are moving from one trophic level to another trophic level, the concentration of that contaminant is increasing. So for example, if there is mercury in the water body, the mercury will be taken up by fishes, right? The concentration will be very low. Then these fishes will be eaten by big fishes, and the concentration of this mercury will be higher in big fishes. So what does it mean? That if we are moving from one trophic level to another trophic level, the concentration of pollutant or contaminant is increasing in the body. So there is a difference between these two things, bioaccumulation and biomagnification. And most of the time it we can see this bioaccumulation and biomagnification in plants and animals, right? And can you tell me the environmental compartment we have? So, environment compartment, maybe air, maybe water, maybe soil and sediment, maybe plant and animal. Right now, what we are seeing that plant and animal are the environmental parameter, but compartment, but not the receptor. Because right now we are just focusing human as the receptor, and plant and animal we are referring as the environmental compartment only, right? I think this slide will help you to understand uh, bioaccumulation and biomagnification. With the time within a fish, the concentration of the contaminants are increasing, right? And biomagnification is in the trophic level, coming trophic level, the concentration is increasing. So in the plant it was minor, then to the insect it was medium concentration, and to the then to the bird or to the eagle, the concentration is increasing. So this is biomagnification. So can you give me one example of biomagnification? So there is one pesticide, if you have heard about, I want the name from you. There is one pesticide that is giving you the biomagnification, and because of that biomagnification, the shell of some bird are getting thinned, and that's how this bird reproduction is getting down. Can you tell me the name of that pesticide, or you can say contaminant or pollutant? Because of the biomagnification of that particular chemical is uh, is making the shell thin. Okay, so Lakshmi gave me the answer DDT. Yes, so DDT is a pesticide. Can you tell me the full form of this DDT? DDT is a pesticide, and this pesticide is increasing over the trophic level. The concentration is increasing over the trophic level, and that have very adverse impact on reproduction of birds. What is the full form of DDT? Dichloro, diphenyl, trichloroethane. I think that's the right. So you must know some name of pesticide, for example, DDT or methoxychlor or malathion. So we have a lot of pesticide, and I think you must learn about this pesticide and how these pesticide have bad impact on human. Anyway, so I think bioaccumulation and biomagnification is cleared. I think I already have make you understand that bioaccumulation is the progressive buildup of chemical within a single organism over time, and biomagnification is increase in the concentration of chemical across successive trophic level. So I think this is clear right now. Anyway, so the next question is, hazardous material influence human health primarily through which linkage in the framework? Emission to source, toxicity to receptor, environment to emission, exposure to source. Hazardous material, how it can influence the human health. I'm getting B answer. Okay, so everyone gave me B answer. That is toxicity to receptor. No doubt you are right. But again, my question is how you will identify which material is hazardous to you or not. What are different characteristic feature or characteristic we must have to assign that particular material as the hazardous. So I'm just giving you abbreviation, ICRT. If we have these four things, the one thing out of these four things, then we can say that this is hazardous material. Dhanya already have given me ignitability. Yes. So this is ignitability. And C, toxicity. Then R means reactivity. Uh, C is not combustion thing, but something else. You have to think a little bit more about C. You are right about I is uh, ignition, C is reactions or reactivity, T is toxicity. Yes, Rahul, this is not radioactivity, but this is corrosivity. Yes. So this is corrosivity. Okay. The next question is ignition. At what temperature we will anything can be ignite, right? But at what temperature we can assign that particular material as the hazardous? What is that threshold? Below what temperature, if we can ignite it, then we can call it the hazardous material. So what is that particular temperature as a threshold for ignitability? So if it is a 60 degrees Celsius, so if it is a 60, we can ignite it on 60 degrees Celsius, then that will come under hazardous. Okay, corrosivity. At what should be the pH? Because corrosivity is dependent on the pH. So what pH chemical we will assign as a corrosive in nature? What should be the pH of that particular material to assign it as corrosive or henceforth hazardous material? It should be either highly and alkaline or highly acidic. Then only that particular material can corrode something, right? So what is that range? So if any material that have the pH of less than 2 or more than, oh sorry, this is less than 2 and more than what, 12, then we can assign that material as corrosive in nature. Coming to the toxicity, anything that is toxic, right? Reactivity, how we can assign a particular material as a reactive one. What can be the criteria for this? So anyway, I think that I have in the next slide. But the thing is, under the hazardous material, we have toxic. One characteristic is toxic, and if that particular material has the toxicity, then toxicity can be uh, taken by the receptor. So this is how this B is the right one. Its interaction with surrounding reactivity, yes. Among the option, if it was the reactivity or so among that option, B is the right one, and but it can be anything, right? Okay, so we already have learned this, that we should have four characteristics to make any material hazardous. One out of these four: ignitability, corrosivity, reactivity, and toxicity. And this is, I think, you need to learn. Uh, if there is any chemical that is ignitable, then the flash point should be below 60 degree, right? For the chemical to be corrosive, it should be either less than or equal to 2 or greater than or equal to 12.5. Somewhere it is 12. Reactive chemicals ignite or create poisonous vapor when mixed with other product, or can explode when exposed to heat, air, water, or shock. And toxic means that may cause long-term illness. And that's how this is one characteristic of the hazardous material that have direct impact on the receptor. Okay, so the next question is, I have two statement. Not all emitted pollutant result in human health effects. Human exposure depend on transport and transformation of pollutant in the environmental compartment. And you have to tell me the right answer among these four options. A and R are correct, and R explain A. A and R are correct, but R does not explain A. R is true. So A is true, R is false. A is false, R is true. What do you think? Okay, Dhanya told me that both statements are true, but R does not explain A. But I think A option is the right one. Yeah, Rahul and Lakshmi gave me A. Okay, so actually, A is the right answer, and let me know you how. So, for example, if we have carbon monoxide, right, and that carbon monoxide is more in the cities, right? And if you are in a rural area, then you will not have that exposure of carbon monoxide. Why? Because of the transport and transformation. Because it has to transport from urban to rural area, right? And in between that, CO may react with oxygen and may give you CO2, and that's how the impact of this carbon monoxide will be lesser. Why? Because there is some reaction, there is some transformation, there is a transport in the environment. Because of that, the emitted pollutant may you may expose to that particular emitted pollutant in the lesser amount or in the more amount, based on the transport and transformation. And that's how A is the right answer because R is explaining A also. Can you give me more example of this? So you have to take here the emitted pollutant. Emitted pollutant, the pollutant that is coming from the source, right? Or this emitted pollutant may or may not give you the same exposure whenever you are, let's say, a few kilometer away from, let's say, the city center, because of the transport and transformation. And that's how the exposure will vary where you are, and that's how this R is giving the explanation for A. I think, Danya, is it clear right now why I'm saying the A is the right one? Okay, thank you so much. Okay, so this is slide that I have taken from NPTEL only, and I think this is very clear right now. We have source, and as I told you, source is mostly the process, right? So either it is the combustion, or it is the manufacture, or it is the transportation, because this process will emit some pollutant, right? Will emit some pollutant. That pollutant will go to the environment, and we have different environment compartment, for example, air, water, land, animal, plants. And there will be some transport and transformation of that pollutant A in the environment, right? There will be some changes in the environment, in pollutant A. And then after making some changes, there are some exposure pathway, by breathing or by mouth or by skin. We can have that pollutant A by the human, and that's how human will be exposed to that, and human will be the receptor of this hazardous material, right? So this we already have learned right now. If there is any problem, you can let me know, otherwise we can go further. Okay, the next question is, now we are moving from simple to little advanced. Washing coal before combustion to remove ash and sulfur is best classified as exposure reduction, environmental transformation, emission control at source, receptor based intervention. What do you think? What is the right answer for this? If we are washing the coal before combustion to remove ash and sulfur, what we are doing? Are we reducing the exposure? Are we doing the environmental transformation? Are we controlling the emission at source? Or this is receptor based intervention? Okay, Lakshmi and Rahul gave me C answer, and you're right. So, so this is something, because we have learned that cycle, or not cycle, but is the linear process, that from source to environment to exposure to the receptor, right? And source, so combustion, if we are having the combustion is the process, and that process will come under the source, right? Before combustion, if we are improving our fuel, for example, coal, if we are washing that coal, and this is how we are removing the sulfur content from the coal, this is how we are reducing the emission of the contaminant, right? And that's how we are controlling the emission at source. So it means, if we exactly know the source, the process at the source, and the environment compartment, and receptor, then we can intervene and we can control the exposure to the human, right? So this is the one example. Can you tell me, we have, in the coal, sulfur is in two form, right? One organically bound and one is inorganically bound. So if it is inorganically bound, in what form that sulfur will be present? because washing the coal will just remove the inorganic sulfur. It will not remove the organic bounded sulfur. So my question is, what is that compound, inorganic compound of sulfur, that we have in the coal and that we can remove by washing it? Have you heard about pyrite? Can you give me the formula for this? So the sulfur that we have coal in the inorganic form is pyrite. Can you give me the formula for this pyrite? Um, Sulfide form. Obviously, in the pyrite, we will have sulfur, right? So it is, have you heard about this FeS2? Oh, I was just asking the chemical formula for sulfur-bound compound that we have in the coal. So in coal, we have FeS2, that is inorganic, and that inorganic sulfur we can remove from the coal by washing. But inorganic, I don't know like what is the exactly uh, R2S. I didn't understand, but are these RHS, RS? I think you are trying to make me understand, but I'm not able to exactly. But anyway, so I think this is clear that inorganic form of sulfur we can remove from the coal by washing it, right? But to remove the organic bounded sulfur, we must have some different reactions, but not just by washing. So that's how C is the right answer. Okay, the next question is, which of the following represents an exposure control rather than an emission control? I have some question regarding the course and assignment. Could any of you please share your email address or contact number so that I can clarify a few? Obviously, Sandeep, I will give you my email ID, and I think some of the people may also give you. I don't know, but yeah, at the end, I will give you my email ID. Like if you will have any query or question about the presentation or about the course. So anyway, so we are on the question that is, which of the following represent an exposure control rather than an emission control? And we have four options here: installing electrostatic precipitator in chimney, washing coal before combustion, using face mask in high air pollution zone, and switching to low sulfur fuel. So in last question we had the emission control, right? And in this question we have exposure control. You have to make the differentiation. Okay, so someone have given me, Rahul has given me C and Dhania A, but what I think is C is the right one, but I will not deny that A is wrong, because A is right also, because if we are installing electrostatic precipitator, no doubt it is um, uh, it is something that we are not right now. I have quiz at 7 p.m. Okay, okay. I think you may leave actually if you want to prepare. Okay, so what we are talking about, we have right answer, that is C, but A is also the right answer indirectly. How I can say, for example, if we have the receptor, so this is, let's say, human, and if we are having the mask or some filter or let's say air filter, and that's how we already have contaminants in our air, and we are just removing that contaminant uh, removing that contaminant, or we are reducing the exposure to it by using face mask. So this is how we are having the exposure control. But this is also right actually, because whenever we have air pollutant, uh, that air pollutant already has been emitted, but before going to the environment we have to control it, and this is using the electrostatic precipitator. So that's how it is indirect, not right direct answer, because it it has not emitted already. It is in the chimney, or it is in the particular chamber, but before moving to the environment um, we are removing it, right? So this is not same as we already have emitted in the environment and then we are having the mask to reduce it. So it is indirectly correct, but not perfectly correct, right? Okay. So, in the source emission receptor framework, transport and for transformation of pollutant primarily occur at which stage? So, you have source, emission, environment, exposure. You have to tell me the process, that is transport and transformation, will happen at what stage? Either it is at source or emission or environment or exposure. Okay, yeah. So yes, this is environment actually. So within environment, there is the transportation of pollutant from one place to another place. And the second is there may be some modification in the pollutant or the contaminant in the environment. So this transport and transformation uh, are the processes that happen in the environment. And that's how C is the right answer. I think you people already have seen this type of figure. So, so for example, we have some combustion, or we have different industries, we have heaters, we have traffic, we have, and these traffic industry heater are giving different contaminants or pollutant in the atmosphere. This may be heavy metal, hydrocarbon, nitrogen oxide, sulfur dioxide, and there will be dispersion, that is transport and turbulence. There may be transformation, modification in the contaminants, and that's how it. So for example, if it is nitrogen oxide, right? So for example, it is NO2. That NO2 may be transformed to nitric acid, right? Sulfur dioxide may be changed into sulfuric acid. So this is how there is a transformation, and there is dispersion or transport also. In near to the chimney, the pollutant will be in higher concentration, right? But if you will go away or 1 kilometer away from that chimney, uh, the pollutant will be dispersed, and that's how the concentration will be lower, and then there will be the deposition. So whatever is happening, either it is transport or transformation, that is happening in the environment, and that's how that C answer was the right one, right? Okay. The next question is, providing household with water filter to remove arsenic from groundwater primarily reduce what? Emission, environmental fate, exposure at receptor level, toxicity of arsenic. So if we are having the water filter, for example, ACE, RO or something, and so what it is controlling. Okay, so Rahul gave me C, and Lakshmi also told this is the C, exposure at receptor level. Yeah, so we are reducing that exposure because you know that arsenic is very poisonous in nature, and if we are having the water with arsenic contaminant, that may give you different disease. And that's how we are reducing exposure to arsenic by filtering it, right? And that's how C is the right answer. Okay, so the question is, can we intervene? So there is a framework from source to environment to yeah, environment to the receptor. So can we intervene? Yes or no? So if we are having big industry, and that big industry is giving heavy metals or a lot of volatile organic compound, and that is being released in the environment, so can we reduce the exposure? Yes or no? Can we reduce the exposure? Can we do some intervene in that? Yes. So this is yes. And how it is possible? If we know exactly the environment, if we exactly know the exposure, if we know exactly the source, then only we can make any intervention, right? And that's why it is important for us to know the characteristic of the pollution, characteristic of any pollutant, either it is water pollutant or air pollutant. We also have to learn about the environment compartment, because different environment compartment can make some changes in the contaminant, right? And may alter the exposure. That's how it is important for us to learn about environmental compartment, to learn about the characteristic of air pollutant, water pollutant, any kind of pollutant, and then the about the receptor, right? And that's how right now we will try to understand. The next part is to understand the environment compartment. So for example, if we are talking about the soil, we may have in the soil we have sand, we have silt, we have clay. Okay, but different type of soil will have different interaction with the pollutant, and that's how exposure will be varying. That's how we need to understand the type of soil we have, how this soil may changes in the concentration of contaminant. If it is a water, then what kind of water bodies we are talking about, and uh, its impact on the contaminant exposure to the receptor. So anyway, so right now we will talk about the environmental compartment and how within that soil, water, air, we have variety of compartments, right? Sub compartment. So next MCQ question will be based on that only. Okay, I think very simple. In the context of environmental compartment, we have two systems, lotic and lentic system, that are best described under what? Atmospheric compartment, terrestrial compartment, aquatic compartment, biotic compartment. I think the person who already have some knowledge on environment can give this answer very easily, but I'm not sure that some engineering person can give the right answer for this. But anyway, Lakshmi and Rahul already have given me the C answer, that is aquatic. Yes. So within water compartment, or you can say aquatic compartment, we have two systems, the lotic and lentic. The next is Shreya Naidu is also giving me C answer. So the next question is, what is the difference between lotic and lentic system? I think next question is on that. Okay, so you just need to see, in the lotic we have river like thing, right? Yeah, Lakshmi gave me a right explanation for this. Lotic means moving. So we have river, right? River is flowing with some speed. Then this will come under lotic system. And if we have lentic, so for example, if we have lake, lake is not moving, the water is stagnant, and that's how this will come under the lentic system. And you must have to understand the fate of contaminant in two different system. Either the contaminant is in lotic system or lentic system, the fate will be different, right? Okay, I think I already have given the explanation for this, but I think you can give me the answer for this question quickly. Which of the following correctly distinguishes lotic from lentic water bodies? Lotic stagnant water, lentic flowing water, and so on. So you just see the option and try to give me the answer. Okay, Lakshmi and Rahul is giving me the answer C. Vasudevan C. Shriya C. Okay, yeah. So just keep in mind, lotic means flowing or moving, and lenting means stagnant, right? So that's how C is the right answer. Okay, so because I was talking about the fate of any contaminant in two different systems, so a pollutant discharged into a lotic water body is generally expected to show which dominant environmental fate. Long-term accumulation in sediments, rapid dilution and downstream transport, thermal stratification, enhanced biomagnification. What will be the fate of any contaminant that we have discharged into the lotic water body? So Rahul gave me B and Lakshmi also gave me B. Yeah, whenever we have flowing water, for example river can, so if we have one contaminant at one particular point, the river can carry this pollutant to the another place and can disperse it. Okay, and that's how it can dilute it. So if you have seen that we have a lot of industries, and industries are discharging a lot of wastewater in the river bodies, but what will happen whenever it is discharging at that point, the contamination will be very higher, but with some distance the pollutant will be in lower concentration because it has been diluted, right? And that's how B is the right answer. You probably have seen this curve. This is very important curve actually. So this is the place when we discharge some wastewater. So let's say it is the sewage water we have discharged. Then what will happen? Our dissolved oxygen in the water body will reduce, okay, near to where we discharged the water, polluted water, right? So here our BOD will be reduced, but with the time, because there will be the dilution, there will be some microorganism will work on that pollutant, and that's how due to transportation, due to dilution, due to uh, microbial decomposition, that that pollutant will be reduced, and this is how over the distance the dissolved oxygen will be increased. Okay, but here also you can see the biological oxygen demand will be higher near to where we discharge the sewage, and then it the biological oxygen demand will be decreased. So this is very important curve actually, and this is also showing you that if we have lotic system, moving system, then pollutant will be diluted over the distance, and that's how exposure will be lesser. Okay, so the next question is, from an environmental risk perspective, contaminants are more likely to persist over longer duration in lotic system due to turbulence, lotic system due to dilution, lentic system due to low flow and sedimentation, both system equally. Yeah, I think C answer is right because we already have talked about this, right? If something is moving, then there will be transport and dilution. But if something is stagnant, not moving, then there are higher chance that that contaminant will be there for longer period of time, right? And that's how the C answer is the right one. So I think you already have seen that algae that we have, and that algae and that eutrophication. Have you heard about the term eutrophication earlier? So this is the case of eutrophication. So most of the time, 99.9% eutrophication will happen in the lakes, not in the river, because river are flowing. And can you tell me the minerals or nutrients by which eutrophication happens? There are for example, we have detergent, and if we are discharging the detergent water in the lake, then what nutrient we are providing to the lake so that okay, Lakshmi wrote increase in the nutrient DO is reduced due to decomposition. But yeah, you're right. But I'm asking what kind of nutrients we are talking about. Can you specify that particular nutrient? It is carbon or something? Rahul told nitrogen. Yes. Dhania, phosphorus, yes. So mostly these nutrients are nitrogen and phosphorus. So the thing is, maybe some industries, for example, if it is a fertilizer manufacturing company, okay, that company is discharging the water to the lake, and so that lake will have mostly nitrogen and phosphorus because we need that nutrient for the fertilizer, right? And that's how if there is a lot of nutrients in the lake, then what will happen? There will be a lot of microorganism, and that microorganism will die, that sediment will be at the bottom, and that's how the lake will be die. Okay, so this is something that we known as eutrophication. So eutrophication is the excessive amount of nutrients that when we have in the water body, that will lead to the eutrophication, right? And most of the time this eutrophication is happen in the lakes. Why lake? Because the water is stagnant, water is not moving, there is no dilution. Okay, we don't see that eutrophication in the water body. Why? Because the nutrient are getting diluted, and that's how the water body, you will not see river have any kind of eutrophication, but lake has. So this is the important of what different type of compartment we are dealing with, and that's how the contaminant will be in higher quantity or lower quantity based on what compartment we are talking about, right? So this is very important to know. Okay, so coming to the next question. Ah, I think. Um, okay, so I think this we already have covered that lentic, that is stagnant. The stagnant water will have higher contaminant residence time, and the lentic system have limited water movement, and that's how it will promote the sedimentation and accumulation. So I think this is clear to all of you that why this is the case. Okay, so till now we talked about water bodies, and these water bodies were lake and the river. So now we are moving to groundwater actually. Though so groundwater is also one environment compartment. So here we have one term that is VDOS. So VDOS zone refer to what? So we have four options: the zone where all pore spaces are filled with water, the zone below bedrock, the unsaturated zone between land surface and water table, the confined aquifer zone. Okay, so I already have received the response from Lakshmi, Dhanya, and Rahul, and these are C. So that is unsaturated zone between land surface and water table. Yes, you are right. So I think you already have seen such kind of picture. So we this is our zone of saturation. So zone of saturation means each pore is filled with water. So we have pores. So let's say this is the pore, and this pore will be filled with the water everywhere. If it is filled with water but not with air, then this will be the zone of saturation, and this will be your groundwater. So these are your groundwater, right? But in that area, we have, this is the zone where we do not have saturated but unsaturated. This is unsaturated zone, means the pores are not only filled with water but also with the air, and that's how this is unsaturated zone. And so here we will not have uh, water that we can extract out to the ground. So this is the widow's zone, and this layer that is uh, between zone of saturation and widow's zone is known as the groundwater level, right? This is the groundwater level. So widow's is unsaturated, a zone where we have a pore that is filled with water and air. Okay, I think this I already have given the answer for this. In the widow's unsaturated zone, the pore space are occupied mainly by only water, only air, both air and water, only mineral. I think this is very simplest question I asked. Yeah. So Lakshmi gave me answer C. Vasudhevan is also giving me the answer C. So yes, this is the zone where we have both air and water in the pore space. Uh, that I already have explained. The water table represent what? The boundary between soil and bedrock, the upper surface of the saturated zone, the base of the widow's zone, both B and C. How you will, what do you mean by water table? Okay, so Rahul has given me D answer, and yeah, D answer is the right one. So you can say water table in two ways. The one is it is the upper layer of the saturated zone, or you can say it is the base of unsaturated zone, right? And that's how this two way of saying the water table is same, and that's how both B and C. That means D is the right answer. Okay, now this is now we are moving to the another compartment, that is soil. Which of the following soil friction is most dominated by uh, silica oxide as shown in the mineral composition? Clay, silt, sand, organic matter. I will say, Rahul, again read the question. Which of the following soil friction is most dominated by silica oxide in the mineral composition? Is clay, silt, sand, or organic matter? Maybe I'm confusing you. Okay, you are stiff to your C only? Yeah. So yes, C is the right answer. So if we are talking about the sand, so sand mostly have silica oxide, right? And can you, okay, that uh, different chemical composition or mineral composition of different type of soil will also decide the fate of the contaminant, right? I think in next few question that thing will be clear to you. Which soil fraction has the smallest particle size, highest surface area, making it most reactive for contaminant adsorption? Sand, silt, clay, gravel. The soil fraction that have the smallest particle size, that have the highest surface area, and that is making it more reactive for contaminant adsorption. Rahul and Vasudevan gave me C answer, and yeah, so the most reactive uh, soil fraction is the clay. Yeah. Why clay is the right answer? The first is it has very smallest particle size. The second is it has the highest surface area, and the third is its chemical composition. um, we already have talked about sand, right? The sand is made up of mostly SiO2, but if you will see the chemical composition of the clay, there is a lot of cations, which is clay is made up of a lot of cations, and that cations will make the surface uh, charged, as a charged one, and that's how it can attract different ionic form of the contaminant, and that's how this will react with that contaminant, right? So yeah, C is the right answer, that is the clay. I think you already know about this, that sand have the particle size is largest, that is 2 to 0.05 mm. Silt is intermediate, that is 0.05 to 0.002, and clay, the size is less than 0.002 mm. Okay. Which soil component is rich in oxides of aluminium, iron, magnesium, calcium, contributing strongly to the adsorption processes? Sand, silt, clay, bedrock. Which soil have is rich in oxide of some cations, as I already have talked about this: aluminium, iron, magnesium, salt, calcium, that will contribute strongly to the adsorption process. Yeah, Rahul, Lakshmi, Vasudhevan already have given me answer C. Yeah, so this is clay. We already have talked about this, right? Because clay have such chemical composition that it is a kind of reactive site on which a lot of reaction can happen. So this is the one type of clay. Have you heard about this kaolin? So kaolin is one type of clay. So in clay also we have thousand of formula chemical composition, and so we have different type of clay, and the one is kaolin. And if you can see that we have site that is aluminium, silica, oxygen, hydroxide. So we have such kind of ionic form that we have in the clay, and that's how it is. This is making it the reactive one, right? Okay, so the next question is: a contaminant moving downward from the soil surface reaches groundwater primarily by evaporation or surface runoff, infiltration and percolation through the Vadose zone, and capillary rise. I think very simple question. Mm, Okay, so I'm getting answer C, that infiltration and percolation through the Vedas zone. Obviously, for example, if you have rainfall, and that rainfall will meet to the groundwater uh, through that Vedas zone only. So this is how it will percolate and it will infiltrate right through the Vedas zone, and then it will meet to the groundwater. The another can be runoff also, but for runoff, it will be in some water body that have direct connection with the groundwater. Then only the runoff can reach to the groundwater. So C is the right answer. This I already have shown you, so I don't think. Anyway, clay rich soils often reduce groundwater contamination. Clay mineral have small pore size and high adsorption capacity. And you have to give me the answer out of this A, B, C, D. Mhm. How we can reduce the groundwater contamination? What kind of soil fraction we should have? Mm, Rahul gave me A. Yes. Okay. So yeah, A is the right one, because we already know that if there is a some kind of contaminant, and that contaminant we have on the surface, okay, and because we have the clay, the contaminant will be absorbed by clay only, and it will hinder the contaminant movement to the groundwater, right? Because it is absorbed by the clay rich soil. So this is how the contamination to the groundwater will be reduced. So this is how, this is the important of understanding the different environmental compartment, right? We talked about how the lotic system is different from the lentic system, because it will have direct impact on the contamination, right? And again, if we are knowing the soil fraction, what different type of soil we have, and the chemical characteristic of the soil, this is how we can also help to reduce the groundwater contamination, because we know that clay is the best one. So most of the time when if you have heard about the landfill, sanitary landfill, then most of the time we have the layer of the clay around it. And why there is the layer of clay? Because we know that that will help us to reduce the percolation, or you can say the leachate of the sewage, or the contaminant from the landfill to the groundwater, because we are exploiting the property of our environment compartment. So that's why for the intervention it is very important to know about the environment compartment. And this uh, clay rich soil is one of the benefits that we can have to design any kind of filter, right? A filter for mostly for water, right? Anyway, so because we already have talked about different environment compartments, now we will move to the pollutant characterization. So for example, if we have like what different type of pollutant we may have in the environment, or in the air or in the water, or what kind of property it has, so that we also need to learn. Because if it is a again, if it is a clay, and we know that for the clay we have the cationic ions we have on the clay, then what kind of chemical it can absorb and what kind of chemical it can't absorb, right? So the property of contaminant uh, is also essential for us to know, right? And that's how now we are moving to the pollutant characterization. uh, Okay, so which of the following pollutant is best classified as an aromatic organic compound? We have methane, ethane, benzene, sodium chloride. Very simple, I think. Okay, so Lakshmi and Dhanya gave me C answer, that is benzene. Yes. Shreya also gave me C. Yeah. So aromatic means mostly whenever we have benzene structure, then we call that as aromatic organic compound. But this is very rough definition actually, because to classify some compound as the aromatic, there is 4 or 5 condition that we need to talk about. But I think because we are not chemistry people, so I will not go into that. But very rough definition is whenever we have benzene like structure, then we can call that as the aromatic organic compound. And so the benzene is itself an aromatic organic compound. So what we got is pollutant can be aromatic organic compound. And you know that solubility, reaction, or the reactivity of organic and inorganic is different. The first thing, in the organic also we have aliphatic and we have aromatic, and the solubility is again different, and even the reactivity. So we must have to understand what uh, what pollutant is organic in nature, what is inorganic to nature, what is aliphatic in nature, or what all are will come under aromatic. And based on that we can characterize the solubility of that reactivity based on the environment compartment we have. So this is very important to know the characterization of pollutant, right? So yeah, C is the right one. Okay, so from here, what we learned is that if we have benzene ring, then this will come under aromatic compound. If we have aliphatic C, C chain, then a C linear chain or branched chain, that will come under aliphatic. And we have biphenyl also. Very important category of pollutant is biphenyl, because most of the time these are cancer causing pollutant, right? So whenever we have two benzene attached with one line, that will come under biphenyl. Okay, so the next question is, which of the following is correctly classified as an inorganic pollutant? And we have four options here: polycyclic aromatic hydrocarbon, chlorobenzene, mercury, and biphenyl. So, Lakshmi C, Dhanya A. Why A, Dhanya? Rahul C. Yes. So, okay. So, whenever we are talking about inorganic, mostly inorganic doesn't have that C chain, that is the carbon chain, right? And mostly in inorganic pollutant, we will have the heavy metals, we will have some ions and some oxides, but in organic form we will have that carbon chain, right? Keep in mind that if it is organic, then we have the carbon hydrogen chain most of the time. So mercury is the one that is not organic, but it is a inorganic pollutant. Yeah. um okay, it's all right, Dhanya. So yeah, C is the right answer, that is mercury. So can you tell me more inorganic pollutant that we have in the environment except mercury? Can you give me the name of some inorganic pollutant that we have in the atmosphere right now or in the water? Chromium, yes, you're right about the chromium. What more we have? Inorganic pollutant. So mostly in inorganic pollutant, we will have elemental form of any element, or heavy metals, or some ions. SO2 exactly. Uh, it is. You can say inorganic, but we are not classifying this SO2 in any kind of like such categories. But yeah, it can be come under inorganic. Lead, zinc, arsenic. Yes, you gave me three, Rahul. That's right. Lakshmi, cadmium, arsenic. Yeah, so these are mostly heavy metals, right? But how you will classify that particular is the heavy metal and particular is not the heavy metal? So is there any threshold or definition for like within inorganic pollutant we have the one category that is heavy metals, and you gave me the example of lead, zinc, arsenic, cadmium, and most of these are the heavy metals. So how you can classify heavy metals from the metals? Is there any criteria for this, any threshold for this? You can check about the specific gravity. There is a specific gravity, maybe I think four, if I'm not wrong, but you can check. But based on the specific gravity, we can classify whether this element is heavy metal or not. Yeah, so you have a lot of examples about this inorganic pollutant, and one is mercury. Okay. Which of the following is best classified as an inorganic salt pollutant? We already have talked about heavy metals, but right now this is salt pollutant in environmental system. Benzene, sodium chloride, polychlorinated biphenyl, phenol. Yeah. Lakshmi and Rahul already have given me B answer, and yeah, you people are correct. This is sodium chloride only. Sodium chloride is inorganic salt. Okay. Um, this is nice question actually. Which of the following metal commonly exhibit multiple oxidation state, influencing its mobility and toxicity in the environment? Sodium, calcium, iron, chloride. I think in my option, I already have given two oxidation states. Then obviously it will be very easier for you people to give me the right answer. But yeah, yes, C is the right answer because the oxidation state of iron may be multiple, and because of that, its mobility will be increased. But you have to keep in mind that some of the oxidation state will precipitate it out, and that's how its toxicity will be reduced. But some of the oxidation state can make it highly mobile and highly reactive and highly toxic. So you have to keep in mind whenever we have multiple oxidation sites that can give us the benefit, but as well as it may be curse for us, right? So iron is one of them. Okay, the next question is which heavy metal is correctly matched with its toxic ionic form frequently encountered in environmental contamination? Little tough, but I think you can answer it. Sodium, mercury, potassium, calcium. And the first thing I think very easy to detect is this is the heavy metal, right? And which is matched with its toxic ionic form. I don't think that sodium, potassium, and calcium are heavy metals, right? And that's how your option B will be the correct one. Yeah. So we have mercury, and if we have oxidation state 2, if we have, then this is the toxic ionic form of the mercury. Okay, because we already have talked about heavy metals, and you must have to learn what are different source of these heavy metals and what is the famous disease or syndrome we can have from that particular heavy metal. For example, if it is a lead, then lead is present in paint or batteries or smelting or old pipes or gasoline. and that can target nervous system, blood, or kidney, and that's how it can lead to the lead poisoning in the human, and that's how it will affect the human health. And that's how we have if you are preparing for, let's say, UGC net or something like that, then there is a one important question that net will always ask you out of this heavy metal, that for example, if it is a minimata disease, then this minimata disease is caused by which heavy metal? So this is mercury. So I think you need to learn these things if you are preparing for any of the competitive exam, like environmental net or something. Anyway, which of the following statement about arsenic and fluoride contamination in India is correct? Arsenic contamination is mainly found in Western India, while fluoride contamination is widespread in the Ganga Brahmaputra basin. Both arsenic and fluoride contamination are only due to industrial pollution in India. Fluoride contamination mainly affect groundwater in arid and semi-arid region, while arsenic contamination is common in the Ganga Brahmaputra basin. Neither arsenic nor fluoride contamination affect drinking water source in India. What do you think? What is the right statement for the India about this arsenic and fluoride contamination? Vasudevan gave me answer C. Okay. More answer. Can I expect more answer from more people? Or where the arsenic is present in India, where the fluoride is present, and that's how. Yeah. Lakshmi gave me C, I think. Be sure, and yeah, C answer is the right one. So yes, so if we are talking about fluoride, then fluoride is mostly in arid and semi-arid region of India, in the groundwater. And if we are talking about the arsenic, then this is mostly in Ganga Brahmaputra basin. Can you give me the name of two states where arsenic problem is very huge, or the one state where arsenic problem is very huge in India? Rahul gave me West Bengal. Yes, you are correct. West Bengal and Bangladesh. Yeah, Bangladesh is a country, but yeah, Bangladesh and West Bengal have, yeah, highly contaminated with arsenic, and due to the geological formation. So there are some rocks, and in that rock there is a lot of minerals that we have inside the surface, and that is giving you the arsenic in the groundwater. So this is natural source of arsenic we already have in West Bengal and Bangladesh, and that's how we have a lot of arsenic contamination in water, groundwater there. But if we are talking about fluoride, then mostly it is in arid and semi-arid region of India. So this is, I think, you can see such kind of figures. Um the first is for the arsenic, and if you can see, this is Ganga Brahmaputra basin where we have a lot of arsenic, and in West Bengal we have a lot. But if it is a fluoride, then just see the Rajasthan and Haryana region where we have a lot of fluoride contamination in the groundwater. Okay, we already have learned about bioaccumulation and biomagnification, but we have another terminology, that is bioconcentration, and you have to give me the correct definition of bioconcentration. So I have four options here: the breakdown of pollutant by microorganism in soil, the process of pollutant being excreted by organism into the environment, the accumulation of substance in an organism to higher level than in surrounding environment through direct contact, the dilution of pollutant in large bodies of water over time. So that C option have a long explanation, and I think that is the best catch to get the right answer, right? So yeah, C is the right answer. That whenever, as a living person, if we have more contaminant in our body as comparison to the environment, then we will call that situation as bioconcentration. It means in the living body we have more concentration of that contaminant as comparison to the environment, so this is bioconcentration. So I think we already know about these three terms: biomagnification, bioaccumulation, and bioconcentration. Okay, how we can calculate this bioconcentration factor? Dividing the chemical mass by organism body weight. Concentration of chemical in organism divided by concentration of chemical in environment. Concentration of water divided by concentration of chemical in organism. The total biomass of organism multiplied by chemical volume in environment. And so, as I told you, the chemical in the organism or the living body and chemical in the environment. And that's how B is the best suited answer, I think, right? Yeah, Lakshmi and Visudevan gave me already B answer. And yeah, so I think there is no any problem with the B option. Yeah, so this is, you can see the concentration in organism divided by concentration in environment, and this will be bioconcentration. Okay, which of the following does not influence the level of bioaccumulation of an substance in an organism? Just keep in mind that this is bioaccumulation. The rate and mode of uptake, the ability of organism to metabolize or eliminate the substance, the hydrophobicity of organism and lipid content of the organism, the molecular weight of oxygen in the environment. What is the right answer? Which factor will not influence the bioaccumulation of any substance in an organism? Okay, so Rahul gave me D. Lakshmi also gave me D answer. Yeah. So D1 is the right one. The rate and mode of uptake, obviously, how you are taking that, that will be the one factor. The ability of organism to metabolize or eliminate the substance, that is the one of the important one, because how much you are eliminating from your body, this is also, and how much there is the formation or metabolize. So this is important. And hydrophobicity of substance and lipid content, this is again very important, but the molecular weight of oxygen in environment is not. So the answer is the right one. Okay. So, which chemical form of mercury is most toxic to humans due to biomagnification and ingestion through food chain? Elemental mercury, inorganic mercury, methyl mercury, and mercury sulfide. Okay, Lakshmi and Vasudevan gave me C answer, that is methyl mercury. Yes, so if we are having this mercury uh, through food chain or through ingestion by eating, then this is no doubt this is methyl mercury. And can you tell me one incident in which a lot of mercury has been taken up, and that's how the Minamata disease happened? In which country actually? There was a company or industry, you can say, that released a lot of mercury, and that's how bioaccumulation and biomagnification happened, and Minamata happened there. Yeah, Lakshmi gave me the answer Japan. Yeah, you're right. Okay. So the next question is, elemental mercury is particular hazardous because it is highly soluble in water and easily ingested, readily inhaled as vapor and crosses the blood brain barrier, rapidly excreted through urine, non volatile at room temperature. How elemental mercury that have the oxidation state 0 is particularly hazardous? And this elemental mercury is different from methyl mercury. In methyl mercury, uh, that was dangerous by eating, right? But elemental mercury is different because of that oxidation state. Rahul gave me A or B. You are right, and you have to tell me A or B. As I already have told you, methyl mercury was dangerous when we are ingested, right? But elemental mercury uh, will not have much impact by ingestion, but by using different pathway. Yeah. So, yeah, B is the right answer. That is readily inhaled as vapor. Whenever mercury have the oxidation state 0, it means um, it will be in the form of vapor and we can inhale it. And whenever we are inhaling it as a vapor, that will cross the blood brain barrier, and that's how this will be highly hazardous for us. And B is the right answer. Okay. The next is, chronic exposure to candium in humans occur mainly through inhalation, dermal absorption, ingestion, injection. Actually, this is very important because based on what oxidation state the heavy metal has, based on that, the pathway will be different of the exposure. So exposure pathway will be very different for different oxidation state of heavy metals, and this is very important for us to know. Okay, Rahul will again have two options, that is A versus C, and then gave the answer C. Okay, any more answer? How the cadmium will be dangerous for us? Okay, so yeah, this is C, not A, because cadmium is harmful for us when we are eating it through food or water. You just need to mug up this yeah not mug up, actually there is a science based on oxidation state, how it is reacting with different, and based on that oxidation state what kind of phase it is present in, right? So based on that you can estimate. Yeah, so this is the table that I will give you, because I will share this slide to you on NPTL. So you just need to see what oxidation state is most toxic and how, what is the exposure pathway for that. So for example, if it is a mercury, then if it is a methyl mercury or elemental mercury, if it is a lead, cadmium, arsenic, then how it is, what is the exposure pathway. Okay, so we have learned a lot about compartment, environment compartment. We talked about the characterization of our pollutant. Now we will see how we can screen the water quality, how we will judge whether this water is good for us or not. So based on some parameters we will try to learn this. And yeah, so we are moving to this water quality. I have uh, air quality parameter I also have. Let's see how I will be able to cover it or not. But anyway, yeah. So the next question is, during preliminary screening of drinking water quality, which parameter is primarily associated with suspended solid? For suspended solid, okay, so to check whether our water is we can drink that water or not. We have to check the color, we have to check the odor, we have to check the turbidity, or we have to check the taste also. And if we have more suspended solid, so what kind of parameter will be affected much? I think you already have given me C answer, that is turbidity. Can you tell me the unit of turbidity? Very quick. How we can measure? Okay, so then you gave me NTU. What is the full form of NTU? Nephelometric. Yeah, so it is NTU, and the full form of NTU is nephelometric turbidity unit, right? Yeah. So, yeah. So, if we have a more suspended solid, then it means that will give the turbidity to the water. And turbidity is something like this, right? Haziness in the water, or cloudiness, you can say, in the water. If we will have more suspended solid, then that means more turbidity we have. You already know about this. The turbidity unit is NTU. Okay. Which of the following contribute mainly to total dissolved solid in water? Right now, we are not talking about suspended, but it is dissolved solid. And we have option sand and silt, microorganism, inorganic salt and ions, and clay particles. Okay, so you people gave me answer C, but my question is why C? Why it is not sand or silt? Why it is not clay particle? Why it is just inorganic salt and ions that is contributing mainly to total dissolved solid? What is the reason for this? Can you tell me the reason quickly? Why total dissolved solid are mostly inorganic salt and ions? Okay, Dhanya told me that sand and silt stay suspended. Yeah, you are right. But why? Related to solubility, right? Which one have more solubility? Which one have less solubility? Lakshmi told that in water we have sodium, magnesium, calcium, salt. Okay, the thing is, yeah, you people are right. The main thing is that in the water is ionic, right? Is ionic. We have H plus ion and we have OH minus ion, right? So water is ionic in nature. And so if we have inorganic salt and ions, so ions will attract to each other, right? So if we have because we have H plus and OH minus, then this OH minus can attract let's say the calcium, magnesium, and sodium, and that's how the solubility will be more for this inorganic salt and ion as comparison to sand and silt, as comparison to clay, as comparison to organic compounds, right? Organic compound have long C chain, and that are very non-polar in nature, right? Very neutral, and that's how the solubility will be less. If the solubility is less, then it will be suspended in water. But if solubility is higher, for example for inorganic salt, then the solubility will be increased, and that's how this will contribute to total dissolved solid in water. Yeah. So I think so we have different inorganic compound, for example NaCl, calcium carbonate, magnesium sulfate, potassium nitrate, and that will dissociate into some ions. And we know that ions are highly hydrophilic, loving the water, and that's how this will be dissolved easily. But in the case of organic matter, the solubility is very lower because they are hydrophobic. They are not loving the water, and that's how they will remain in the remain as the suspended particles, right? Okay, the odor of drinking water is most commonly caused by what? dissolved non-volatile, suspended mineral particle, dissolved volatile compounds, and insoluble oxides. If we are having any smell from the water, that is due to what kind of compound or salt or particle? Any guess? Dissolve non-volatile. What I learned, Rahul, A and C. Yeah, Lakshmi gave me C. Yeah, actually C is the right one, because whenever you will have any smell out of something, this is the vapor, this is the gaseous form that you will have in your nose. It means it have to vaporize or it has to be volatile. Okay, so whenever we have any volatile compound, so for example, if we have paint smell, right? Or let's say if we have any food smell, so food smell is nothing but the vapor or the water in the vapor form have some gas, and that gas we can smell, right? So whenever we have any smell of the drinking water, this is because of the volatile compounds. Okay, and that's how the C answer will be the right one. So whenever you will percept any kind of smell, that is because of the volatilization. Okay, so we have total solid, we have total dissolved solid, we have total suspended solid. What is the relationship among these three things? So I think this is very basic arithmetic thing, right? Okay, so Dhanya, Shriya, Lakshmi, everyone gave me C. Yeah. So yeah, so this is total solid is equal to dissolved plus suspended. Which water quality characteristic is most strongly influenced by hydrophilic inorganic ions rather than organic compound? Odor, taste, turbidity, color. When we have more inorganic ions in the water, that will give you what? More odor, taste, turbidity, color. Turbidity is mostly by suspended one, right? That will be not dissolved. So I don't think that C is the right answer, is it? Turbidity is due to suspended, and suspended are hydrophobic, not hydrophilic. Rahul gave me B answer. Yes, B answer is actually the right one, because it will give the taste. And why it will give the taste? Such, just imagine that you are drinking Limca or any Coca-Cola. So what are these? So you have water, and in which you have some chemicals that has been dissolved into that, and these chemicals are hydrophilic because these are making a very nice solution, and that's how you can taste different it from the water. So the same situation is like this. The chemicals that we are adding to the water, which are hydrophilic, means which are not suspended, so which are completely dissolved into the water, that will give you the taste. And the inorganic ion are mostly dissolved in the water because these are the hydrophilic in nature, and that's how they will give you the taste. So that's how B is the right answer. Is it clear, Dhanya? Why it is taste? Yeah. Anyway, so coming to the next one. Yeah, microorganism that we have present in the water body, that will contribute to which parameter during screening? Total dissolved solid, taste, total suspended solid, electrical conductivity. Microorganisms, if we have in the drinking water, that will be the form of dissolve or suspended or taste or electrical. Lakshmi, not taste actually, because microorganisms are not dissolved as a solution in the water. Shreya and Rahul gave me C, that is total suspended. Yeah, actually, microorganisms are the part of total suspended solids because they are not dissolved. They are just suspended. They are just present in the water, but not chemically interacting with the water, right? And these are total suspended solid, but not the dissolved, and it will not give you the taste also. The taste may be due to let's say the methane gas produced by the microorganism that can give you, let's say, the taste, or some pungent thing. But as a microorganism that are suspended solid in nature, and that's how these are suspended, right? The color is mainly attributed to what? Suspended solid, dissolved substance, microorganism, insoluble mineral. Color. Color is due to what? Suspended, dissolved, microorganism, insoluble. Rahul gave me B, that is dissolved. Lakshmi A. Okay, you have to understand that color is not due to scattering, but due to absorbance of the light. And absorbance of light will be happen due to dissolved substance. So that's how B is the right one, not A. Yeah. So I think this is the explanation. I think you can read. So color arise when substance absorbs a specific wavelength of the visible light, and so this will be happen when your molecularity will be dissolved and it is uniformly distributed in water. Suspended solid that we have, that will scatter but not absorb it, and that's how it will scatter in all direction and will not give you the color, but it will give you the turbidity. Okay, so this was the crux. If it is a color, then this is due to dissolved substance. If it is a turbidity, this is due to the suspended solid. If it is a taste, then this is due to dissolved inorganic ions. And if it is a odor, then this is like this only. Okay, so I think now it is very clear. Okay, coming to a little bit about the exposure. If it is the LD50 value, then does that mean? LD50. LD50 means what? LD50 means the dose at which 50% of the population will survive, or let's say die. The case is the same, right? So the dose required to kill 50% of the test population. So this is LD means lethal dose, right? Yeah. Lakshmi is right. So this is lethal dose. So lethal dose, if it is of 50, then it means 50% of the population will be died using that particular dose. Oh, I already have given you the answer of this, but which of the following component contribute directly to total suspended solid? So if we are talking about total suspended solid, then suspended solid are mostly particulate matter, and in that particulate matter, we may have microorganism, we may have sand, silt, we may have clay, insoluble salt or oxide, we may also have. So just keep in mind, if you have suspended, it means they are mostly particulate matter, including microorganism. We also have some natural organic matter in the water, and these are what? Can you name some of the natural organic matter we may have in the water? Yes. So these are humic and fulvic acids. So these are natural organic matter that we mostly have in the soil, right? And from the soil, it can move to the water. So humic and fulvic acids are natural organic matter. So in the soil we have these, and just see the molecular formulas of this humic acid and fulvic acid, because next question is based on uh, its solubility to the water, or let's say to the different compound. So just seeing that formula, we have next question: which statement correctly differentiate humic acid from fulvic acid in natural water? So, because the time is less and we have a lot to cover, so I am just giving you the answer. Fulvic acid have low molecular weight but have high solubility than humic acid, right? So you can see the difference between this true natural organic matter later. Uh, okay, very important actually, and I think I can cover this in next session. But these are important actually. So one of the parameter that is very important to know whether our water is clean or not, it is based on BOD, and BOD is biochemical or biological oxygen demand. And what is that actually? So we have oxygen required to chemically oxidize organic matter, oxygen required by microorganisms. So yeah, you people already have given me B answer. So let's say if I have one is very clean water and another is polluted water, which one have higher BOD? Clean water or dirty water? Which one will have higher BOD? Yeah. So Lakshmi Danya gave me polluted. Yes, And if I'm talking about the dissolved oxygen, which type of water will have more dissolved oxygen? Clean or dirty one? Yeah. So yes. So you have to make differentiation between dissolved oxygen and BOD, right? These are inversely related to inversely actually. So yeah, the oxygen that we require by microorganism to biodegrade any organic matter. So this is BOD. Okay, so we can calculate the BOD, that is the initial dissolved oxygen minus final dissolved oxygen by P. So what is that P? This is the formula to calculate the BOD for after 5 days. So we have dilution factor of oxygen, initial dissolved oxygen concentration, fraction of wastewater in the diluted sample, incubation period in days. It is not A, it is something else. Yeah, it is C actually. This is the fraction of wastewater in diluted solution. So what happened when we have some water sample, and if we have high BOD, and then what we do is we sometime we add more clean water into that, and that is known as the dilution water. So and that's how the wastewater will be diluted with the clean water, and then we calculate the BOD. And that's how, so we have to divide the dissolved oxygen by the fraction of how much wastewater we have to the diluted sample, right? And this is how this is the formula. So C is the right answer. Okay, so the one is BOD, the next is COD. So what is that COD? Chemical oxygen demand, and how it is different from BOD? So first you have to tell me what is COD. Yeah, so COD include both biodegradable and non-biodegradable organic matter. Yes, so Which one will be the higher, BOD or COD? Which one will be the higher, BOD or COD? 1 minute more and then we will leave. Danya gave me it is COD. Yeah. So whenever we have BOD and COD, then COD is always higher or equal to BOD. Okay. We use oxidizing agent to calculate the COD. Can you tell me? Okay, Shreya told me what is COD. Okay, so just see that if we have organic matter in water, that organic matter need a lot of oxygen, right? So how much oxygen? Okay, the thing is we have organic matter, and that organic matter will be degraded or decomposed by microorganism, but for the degradation we need oxygen. So how much oxygen the microorganism need to degrade that organic matter in the water will be known as the BOD, right? So this is with the help of microorganism. But sometimes what we do is we do not need microorganism. We have organic matter in the water and we are just adding some oxidizing agent. Okay, that oxidizing agent will give the oxygen and will degrade the organic compound, and this is how we can calculate how much oxygen is required. So this is chemical oxidation, right? So that's how, if we are oxidizing or if we are degrading the organic matter with the help of microorganism, then this is the BOD. But if we are degrading it, or if we are oxidizing that organic compound in the water using some chemical, then this will be the COD. And the benefit of COD is that it can degrade both biodegradable and non biodegradable compound, right? And that's how COD is always higher or equal to BOD. Is it clear? Shreya, is it clear? Yeah. So my question was the oxidizing agent. This is not A actually, this is C. So we use potassium dichromate. This is very strong oxidizing agent, and we use it using after adding sulfuric acid also, and that's how it can oxidize all the organic matter, and we can calculate how much oxygen that organic matter needed to degrade, right? Either it is biodegradable. So I think we should stop here. I have few more question about this water parameter, and then 5 or 6 question on air. And I think that we can proceed in the next week because the time is up, and I think this is the dinner time. Most of the you people must be in hostel, and you people have to go to the mess like me. So I'm also hungry and I also need to go. So next week we will proceed with a few questions that we have related to the water and few question on air, and then we will move to the next week material that we will have, right? So thank you so much for patiently listening to this tutorial, and yeah, we will meet next Tuesday 6 to 8. Thank you so much. If yeah, if you have any query or problem, you can let me know. Uh, should I increase my pace or something? You can always give me suggestion on that. And yeah, I'm writing my email also. So if you have any problem related to any kind of content, then you can just let me know. I will upload this slide on yeah, on NPTEL, so you can have access to that. So thank you so much, everyone. And I think yeah, you can leave it. Uh, yeah, thank you, Rahul, Lakshmi, thank you, Dhanya, thank you, Shreya. So yeah, thank you, everyone. Yeah, I think this is the time to leave.